Okay, so here's our last couple things as far as function translations go, right? We've still got generic function. C is positive constant, so some positive number. And so our last couple setups are going to be about stretching and compressing the function. So sort of almost like if you, right, had like a silly putty, right, that you sort of took and copied the image and then you sort of stretch it out, or you compress it, right, to make it sort of wider or skinnier. And of course you can do that vertically or horizontally. What's going to happen here is this is going to be if we take the constant and we multiply by the function. Keep our little sort of x squared example going, right? So f of x is x squared, right? So versus the constant times f of x would just be whatever our c is times whatever the function is, right? So just the whole function multiplied by c. Just like in the last examples, right, with our sort of shifts, left down, up right, or the reflections. The difference here is if we're on the outside, we're affecting the y values. If we multiply on the inside, we're going to affect the x's. So this is the y's first. The y's tend to sort of behave a little bit more intuitively. And what happens here is we actually get two different cases, not so much like a positive or a negative, right? What really happens here is we have a case where the constant value is larger than 1, and then we're going to have a second case where the constant is somewhere between 0 and 1. Obviously, if the constant is 0, the thing gets just sort of wiped out, and it's kind of trivial. If the constant is 1, then it's not really having an effect at all, right? Because if we multiply by 1, we're not actually changing what's happening. So if we multiply the outside by whatever our constant is, and it's larger than 1, this is kind of the most intuitive. And what we're going to get is a vertical stretch by whatever our constant is, right? So what's going to happen here is our y values are going to be multiplied by c. So this is pretty intuitive, right? This is sort of exactly what you would expect if you multiply all of your y values by c, and your c is bigger than 1, it's going to stretch them out. It's going to sort of stretch them out. Both my hands in here. Stretch it out this way, right? So from both sides. So this is going to be a vertical stretch. Our case number 2 is if we have a constant that's somewhere between 0 and 1, so some sort of fraction, 1/3, right? 5/6, 1/10, whatever. This is still going to affect our vertical values, but it's going to be a compression. And it's going to be the same idea, right? We're just going to take our y values and multiply them by whatever c is. Of course, if c is 1/2 or 1/3 or something, right, or 3/4, well, then you're going to get 1/2 of all your height values, and everything is going to essentially compress towards the center. The other place we can multiply is if we multiply, so not in front of the entire thing, but if we do f of c times x. So if we do c times x on the inside, again, just a sort of generic x squared, right? If f of x is x squared. So what's happening here, c times x, is it's the constant times the x value, and then of course whatever our sort of operation is on the outside. If we affect the x values, right, if we sort of change something inside of our parentheses, we're going to affect the x's. So in this case, that's going to give us a horizontal change. And we'll split this again into the same sort of case 1, case 2. And so similar to our sort of left-right shifts, the horizontal shifts, they sort of, to a certain extent, were backwards from what your intuition might be, right? When we added to the x, it actually shifted us to the left. If we subtract from the x, it actually shifts us to the right. So what's happening here with our horizontal stretches is going to be if the constant, if we multiply by something that's larger than 1 and we multiply on the inside, what's going to happen is we're sort of increasing, right, doubling, tripling, multiplying by 10 our x values so we go through them faster. So this is actually going to be a horizontal compression. And what's going to happen here is our x values, to sort of accommodate this, what we're doing is we're dividing by the c value. So if we have something like 3 times x, we're actually, tripling all of our x values. We're sort of tripling the speed that we go through them. So coordinate by coordinate, what happens is everything compresses towards the center by a factor of 3, and so all your x values, if you're going sort of like point by point, all of your x coordinates are going to end up divided by 3 as they sort of compress towards the center. Case 2, right, if our c value is between 0 and 1, some sort of fraction, right, 1/2 x, 2/3 x, something like that. So that means we're actually sort of going through the x values slower, right? If I do 1/2 times x, I'm sort of moving through them half as fast. So everything expands outward and goes more slowly. And so this is a horizontal stretch. And then the same kind of math, we're going to do x values divided by c. Now obviously, right, if I divide by 1/2, that means I'm really flipping and sort of multiplying by 2. All my x values, if I divide by some fraction, something less than 1, I'm actually going to be sort of flipping and multiplying, and the x values are going to get bigger and bigger and bigger. So the math here sort of on a point-by-point sort of analysis is maybe a little bit tricky, but in theory, right, the same sort of math holds. We're doing division for the x's. The vertical stuff is much more intuitive, and we're just sort of multiplying by whatever our constant is, sort of a larger number, right, larger than 1 is a stretch, or something between 0 and 1 actually ends up being a compression. So those are our setups. So that's sort of part 3 of these function translations. So all that stuff together, we have sort of shifts left, right, up, down. We have reflections over the 2 axes, and we have these stretches and compresses, both sort of vertically and horizontally.